So let's go ahead and just get started with a super quick meditation. I'm going to do like 20 minutes, leave 10 minutes for questions, and so we're going to go fast and furious here. But let's just take a minute to breathe and arrive. Close your eyes if that feels good. Just taking a nice deep breath. Feeling into whatever's alive in your body right now. Breathing into it, giving it some attention. And particularly notice maybe if there's an area of intensity. Maybe it's an emotional intensity or physical intensity. And just using your breath to give that a little attention, allowance, space, gentle holding around it. And with the exhale, increasing the space around it. Allowing it to expand, just a micro movement of expansion. Breathing in to notice, and breathing out to let go. And opening your eyes when you're ready. So, when I was thinking about what to talk about, I was like, what's alive for me right now? And two things came up. One was this meditation that I had done recently because I was dealing with some anger. And I was like, yes, because I don't often get anger. And so I was like, I want this. I want to feel it. I want to know what to do with it. I want to know how to work with it. And so I was looking for meditations to play with that. And came across Mary Maddox on Insight Timer, highly recommended. She's got a great one for anger. And my experience in that meditation was being allowed to feel the story that was associated with my anger and then allowed to let that fall away and just feel the sensation of it. And what I was left with was a feeling of my own power. It's like, that's what this is. This is a feeling of my own power. And in an ecological context, this experience was in a yurt surrounded by giant trees, gorgeous cedar trees, Doug fir, maple on Aaron Redding's property up in Washington State, named Concrescence. The property is named. But when I had done a ritual with Erica Jones, blessing this yurt, and when I moved into it, I felt the enormity of the power of these trees. Just like these massive beings are the only things that can hold the power of this land, shooting up, up, up. And it was much later that I was doing my meditation on anger, but I felt that before I had felt the power of the trees, and like, I am too small to even live at their feet. Like, there's no room to bloom here. It's so shady. I'm not going to last long here. And when I did that meditation, I was like, oh, the trees have taught me their power. And of course, I'm like, there is a thermodynamic message here. And because what I felt was, in past when I've dealt with anger, it's been, I've allowed somebody to cross a boundary that I didn't even know I had, so I need to figure out where that boundary was and reinstitute it. But this time it was something different. It was feeling like a pushing back. Major Saturn transits. But before I get into that, so this is in honor of Robert, Rick, and Brian, of course, so we're going to touch on a tiny bit of astrology stuff, more thermodynamic Brian stuff. And sorry, Robert, I don't have a whole lot of your particular lineage in here, but just want to give great gratitude and honor for this place, for Esalen, for PCC, where I started in 2002 and came here for the first time in 2002. Been a long journey, and part of what I'm going to talk about in this talk is energy cascading across scale, and one of the models for that is vortexes, the energy of vortexes, cascading from large vortexes to small vortexes in a specific scaling relationship. And so we can think about these as the ripples that go out in a learning process. And so anger. So looking at upcoming transits, we've got Mars conjunct Saturn. So this is the anger of feeling constrained, of feeling like you're trying to put energy out and it's like not the right place for it. So it's being pushed back to you. And we've got this coming up in April, and it's going to be the main aspect sextiling Jupiter and Uranus, which y'all will probably hear more about later. If you're astrologically literate, raise your hand. If you have astrological questions, look around you. Those people, they're not agreeing to give you a reading, but they can answer basic questions. If you've taken one of my classes where I've talked about fractals or entropy, raise your hand. If you have questions about this stuff, look around to these people. They can help you muddle through some of these concepts, because I'm kind of blow through here. So we're looking at anger as negotiating the expansion of Jupiter, the contraction of Saturn. Space-time is also negotiating expansion and contraction through energy's expansion and matter's contraction through gravity. And so we're going in through a subjective lens of anger to get a visceral feel for what these concepts are like, and then we're going to look more at the science of how they can be held. So this is a Coke snowflake. It's a fractal creation that many of you hopefully have seen before. And I like to think of, this was kind of my imaginative experience when I'm like, what are the thermodynamics of anger going on here? And there's this feeling of like spreading out into the world of the energy cascading across scales, smaller and smaller in an outward moving manner. And then when there's not space for the energy on the outside, it kind of gets turned inward. And so this is an opposite direction fractals can go. Fractals can spread out, fractals can involute. And so what we have here is, and I'm going to skip ahead a little bit. The surface area is the same on this image and this image. And the surface area is the heat distributing portion of the object. The volume is the heat producing. So these are created in the same way. You take a straight line and you take out the middle third and you bump it out into a triangle. Boop, 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 same length right there. Same thing, but going inside. Boop, boop, boop. And then you do that with each of these line segments also. Take the middle third and bump it into a triangle, inwards or outwards. So that's how you get the same surface area here and here. And if your energy flow is constant and your surface area is constant, then whether internal or external, you have the same power. Because when I felt that as my own, when I felt my anger as my own power, I was like, what's the physics definition of power? And it's energy per time. And so it's how much energy is spreading out, being released from a specified little surface area per time. It's an energy flow rate. And what I found was that I could see so clearly how anger wants to be acknowledged externally and becomes power over. Whereas when we can acknowledge our own power internally, we don't need that external validation anymore. And then the other piece of it is that while the surface areas are the same, the volumes or the area, I'm talking surface area, which is more of a three-dimensional terminology. It's really the perimeter of these two-dimensional objects. But the interior and the exterior boundary. The interior, the area is increasing. The volume, if it was three-dimensional, is increasing in this direction and decreasing in this direction. And so the physics terminology there, power is energy over time. Intensity is energy over time over area. And so if you have a decreased volume, which is your energy producing, or the way I experienced it was same amount of energy flow packed into a smaller volume. So same amount coming through, but it's coming through a smaller space. And so while the experience is still an experience of your power, it feels way more intense when it's internal than when it's external. And so being able to sit with that internal intensity as your own power can be a valuable thing. And this is not to give advice to anybody on what to do with their anger, because everybody's body is going to need to do different things with their anger at different times. This was just coming from my experience. So I kind of talked about this a little bit already. This is how that Koch curve is built, and this is the increasing length of the perimeter. And it's defined by taking 1/3 of that original line length, taking the middle out. So each of these lengths is 1/3, and there are 4 thirds. And so you've got 1/3 4 times. And if you take 4/3 to the level of scale, so if we take this as the second level of scale, the second iteration of this, 4/3 squared is 1.7, and that gives you the distance, because it's 1/3 of 1/3 times 4 times 4 times 4 times 4. That's how your surface area increases. Kolmogorov scaling is this eddy relationship and the dissipation of energy from larger eddies to smaller eddies. And it's a typical scaling relationship where larger things are fewer, smaller things are more numerous in specific proportion to each other, guided by specific physical laws. And I like the eddies specifically because that is how I think of ourselves, as organized flows of energy Let's go. Eddies are a really good metaphor for ourselves because we can see the transition between fast and slow water, and eddy emerges to break down that gradient between fast and slow. We are gradients between high energy sun and low energy space, and we are the ordered structures across scale with many scales of complexity that have emerged in that gradient to dissipate the energy of the sun. The whole Earth is an organized structure organized across scale in order to dissipate the energy of sun. The whole solar system is dissipating the energy of the galaxy. The galaxy is dissipating the energy of the starshed, which is all dissipating the energy of the Big Bang across scale, right? So the whirlpool example is a nice way to get an idea of this organized flow of water that accelerates the breakdown of the gradient. Fast water slows down quicker by going through this organized flow. Energy dissipates faster by going through our organized flow, biological organized flow, even just physical organized flows of the sun and such. Our knowledge histories ripple out across scale, across those vortexes of exchange of energy. And so this notion of fractal deepening, of this increasing surface area and changing volume, can show up in a number of different areas. And one is Kleiber's scaling law, which is a 3/4 scaling law. And it basically means that the larger something is, the more efficiently it uses energy. The slower it goes, the cooler it is, the slower its heartbeat, these kinds of things. And one might expect it to be a 2/3 scaling law, because 3 dimensions of volume gives us our, mass here. And that's our heat producing volume. And our surface area is distributing that heat. So if you're a very small mouse, you have a very high surface area to volume ratio. You need to produce more heat because you're losing a lot. When you're an elephant, you're losing much less heat compared to the mass that you're generating, so you have to burn cooler. So we are existing at a controlled burn. That is our dissipation of energy. We are organized flows of energy existing at a controlled burn. That is the flow of energy. That is the flow of time, scaling across scale. And so then the question is, why is this not a 2/3 scaling law? Because the surface area is 2-dimensional and the volume is 3-dimensional. But if we take in consideration fractal dimensionality, then we can begin to see how, I'm going to skip ahead to this guy right here. Let's go ahead and do basic dimensionality first. So position, point, 0-dimensional, line, 1-dimensional. And if you take that line and scoot it, you get a 2-dimensional plane. And if you take that plane and scoot it, you get a 3-dimensional cube. And if you take that cube and scoot it, you get a projection of a 4-dimensional object. Obviously, these are all 2-dimensional projections of, in this case, a three-dimensional object that we're trying to represent here. And we can't see 4-dimensional objects, but we know that space-time is 4-dimensional. And so how does time show up but as interior and exterior as a dimension of scale is one way to conceptualize it. The spinning tesseract, the four-dimensional cube is called a tesseract, and this is rotating. And you can kind of see how the internal cube becomes the external cube and turns itself inside out in a kind of toroid motion. So there's a lot going on when we're trying to imagine what's happening in 4 dimensions. And then there's also translating between those dimensions, which fractals allow us to do. So traditional one-dimensional line, fractal dimensionality allows us to do less than 1 dimension because it's not quite taking up the full dimension that it's moving in, and allows us to do more than 1 dimension, so that if you squiggle a line up, it begins to take up some of that second dimension and becomes a between 1 and 2-dimensional line. So the Koch curve that I showed earlier, yeah, that's good enough, is, well, I want this one, is 1.26 dimensional. And so it's a fractal dimension, it's a fractional dimension between 2 dimensions and 1 dimensions, because it's taking up some of that second dimensional plane without defining the entire plane. And the dimensionality is found in same relationship between these 2 numbers. It's just the logarithm of the number of multiples over the logarithm of the scaling factor. How much is that piece shrinking each time? Okay. So then we can also do this, from a 2-dimensional sheet of paper. If you crumple it up into a ball, now it's a 3-dimensional volume, but it's not totally 3-dimensional because there's space in there. So it's between 2 and 3 dimensions. So this breaks it out in a little more detail, going from 0-dimensional point to fractal dust between 0 and 1 dimensions, to a 1-dimensional line, to a fractal curve between 1 and 2 dimensions, to a 2-dimensional plane, to a fractal surface between 2 and 3, and to a solid volume. And so, like I said a second ago, it's a power law relationship that's navigating between the number of multiples, 1, 2, 3, 4 copies of the original in the next iteration. Oops. But they are 1/3 the size. So this is 1/3 of that original line. And so it's this negotiation between contraction, between shrinking, and the expansion of this boundary, which is continually getting longer. It's shrinking and multiplying in order to increase that perimeter. And this is what power laws are defining. They're defining 2 exponential relationships to each other, which expands or contracts dimensionality between unit-based dimensions. Okay, we're going to leave it at that for that slide. So the cool thing about fractal dimensions is because they're a power law, they give us a really nice model to talk about entropy, which is also a power law. So entropy is the tendency of energy to spread out and slow down. And it has the same form. It doesn't look like the same form here, but it's basically the same form as fractal dimension. S is for entropy, D is for fractal dimension. They're both logarithmic relationships between, so in the fractal dimension, it's the number of copies. In entropy, it's the number of microstates, the number of possibilities per macro state. And it's the only law of physics, it's the second law of thermodynamics that has an arrow of time. Every other law of physics is time symmetrical. Our experience of time has an arrow of time. That's not our only experience of time, but it's part of our experience of time that's pretty pronounced. And so when we're looking at where we intersect with the laws of physics according to time, the second law of thermodynamics is it. And if it's a power law, that is continually, where entropy is continually increasing, and it's increasing in the same form as the fractal dimensionality, can we consider that the fractal dimensionality of the universe is continually increasing as the entropy continually increases, and that is the progression of time? The progression of time might not be the entire fourth dimension, but a deepening of matter in density into a fourth dimension by continually increasing density and expansiveness through this internal complexity that is time. So if entropy is continually increasing in the universe, and it has the form of fractal dimensionality, so if we assume that it is a fractal dimension, and it's the only law of the universe that has a direction of time. So it is the direction of time as we can define it scientifically. Our experience is a direction of time. And the deepening of, the space-time is four-dimensional, 3 dimensions of space, 1 dimension of time, wherever it is. I make the argument that it's a dimension of scale. And that this deepening and expanding, the deepening of matter and the expansion of space are complementary. And that continual deepening, okay, so here's the other piece. If we are an organized flow of energy, like a whirlpool is an organized flow of water, it's a holding pattern in a flow of energy. It is not a thing. It's a pattern. Matter continually moving through, energy continually moving through us. And it's deepening across scale in order to break down that gradient between fast and slow water or between hot and cold in us. And that dissipation of energy across scale, like whirlpools dissipate to smaller and smaller whirlpools, like we complexify as we age with finer and finer frequencies of brainwave states, that is our deepening into time. The deepening of matter, like energy is loose waves of energy, light is loose waves of energy, matter is bound waves of energy. So there's a fractal dimensionality happening there, this increasing density. And so back to Kleibler's law, we can kind of talk about it that way. If we're not looking at a 2/3 scaling law, and we're looking, it's a 3/4 scaling law, is the relationship. As body mass increases 10 to the 4th, metabolic rate increases 10 to the 3rd. And so it's a non-linear relationship. But the 3/4 scaling law, if we think of it as not as surface area to volume, but as surface area complexifying towards a 3-dimensional volume, like that sheet of paper rolled into a ball, surface area is moving towards 3 dimensions. Volume, our 3-dimensional body, moving through time and deepening in density, is moving into the 4th dimension of time. So now instead of a radius squared over a radius cubed, we can say we're moving towards a radius cubed over a radius quadrupled. Quadrupled's not the right word, to the 4th power. What's my time check? I'm already over time when I wanted to do. But the last thing that I'm going to say is that black hole surface area scales with, or its black hole entropy scales with the surface area of the black hole, not with the volume. Entropy is largely about the number of possible microstates in a volume, so it's typically scaled with a volume, not with the surface area of an object, but for black holes, it's with the surface area. And so if we consider what does it mean if we take a fractal dimension of that surface area that is approaching the volume of the black hole, can all of the information of the black hole be held on that surface area, and could that be a fractal phenomenon? Just kind of ways to attempt visualizing it. So if we take the, surface area as each of these balls, creating the surface area of the entire thing, then we can start to get an idea of how the volume and surface area can be related across that fractal dimension. And to bring us back to whirlpools, the space-time diagram of a black hole is just like a whirlpool. and the space-time, the 3D representation of a 4D bending space-time. So this is our, we see the sun, we imagine that it bends space-time in a 2-dimensional representation of space-time. But if we try to imagine a 4-dimensional representation of space-time, it starts to look a little bit more like the hypercube. So entropy as time. Time is a fractal dimension approaching the 4th dimension that we normally think of the fullness of time. Entropy is cascading across scale via holding patterns and flow. This was the other part that I was trying to get to. So if we're a whirlpool and there's this holding pattern, if energy is continually expanding through us, we are a holding pattern in that expansion of energy. This can feel like a zooming in. If you've ever watched the Mandelbrot set or anything that's a video of anything that's zooming in, everything is expanding around you in order for you to zoom in. So there's a relativity at play here. Energy expanding around us. Our matter is a holding pattern in that flow of energy that is zooming in. There's our dimension of scale in which time exists. We experience time as a tension between the flow rates across scales, and we experience a deepening of time into timelessness, space being timelessness. As space deepens into the fractal dimension of time, it's deepening into a timelessness. Fractal dimension characterizes the tension between expanding and contracting flow rates that curl around each other, creating complexity across scale. And as the final punchline, I don't react, I tesseract. All right, questions?
What is the difference between fractal dimensionality and measure of curvature? Like if
Yeah, so that's a good question because it can be the curvature that creates the fractal dimensionality, right? And so they're intricate related, but the curvature won't necessarily define the fractal dimensionality in the same way. The curvature will define a curvature on one level of scale. Fractal dimensionality tends to be that curvature on all levels of scale, so that you could see it curved, and if you zoom into that curve, it's going to have little curves in it too. And so it's really a property that's traversing scales, whereas curvature is on one, defining it on one dimension, if that makes sense. Yeah.
When you say that something is less than a full dimension, I'm just wondering, in terms of first-person perspective, could it be because, like, for example, spatial dimensions, we can experience them in both directions, forward, back, left, right, whereas time, we only experience in one direction for most part.
Nice.
Is that why time is essentially less than the full dimension?
I like that conclusion. I don't know. Awesome. Yeah.
Kerri, thank you so much for bringing math to PCC so early in the morning. So I'm curious if you've thought about the relationship between the topology of the brain, and there are some approaches to neuroscience that are approaching us as you were doing as a thermodynamic system. There's the free energy principle, if you're familiar with that, where the brain is described as trying to minimize free energy or minimize surprisal is the metric that they use. But anyways, if you're imagining matter as densifying or involuting in this fractal way, have you thought that there might be any relationship between that patterning and the actual topology of the brain and the way that it's folding as into a kind of time-binding organ or something? Can you
Absolutely.
speak
The
to that?
the patterns of the brain are patterns of nature. Nature, energy flows across scale in branching patterns, in Lie patterns, and there's brain coral. It's not the only place we see that pattern show up. And so, yes, nature does this everywhere.
So the brain is like a picture of this fourth dimension you're trying to describe to us? Like
all matter is.
Right. Okay.
Hey, thank you. That was wonderful, and I appreciate it too. The math. I was wondering if we could go back to the slide where you put the point and then you get all the way to the tesseract. So, yeah. Okay, so this is where I get excited, and I just wanted to observe that, this evolution that you're describing is bounded by infinity on both sides. So, Euclid, when he talks about the point is that which has no part. And that's the moment that Brian talks about at the very beginning of the story of the universe, which when the universe has no part, right? And then I watched this evolution, which, I'm thinking it reminds me of the axiom of Maria, right? So the one becomes two, the two becomes three, and out of the three come the fourth as the one. And the tesseract is like this kind of wild way of trying to describe whatever that turiya, that fourth state, right? Anyways, I just wanted to make that observation because I think it's so fun.
Absolutely. Beautiful. Thanks for bringing that cosmological connection in.
Hi, Dr. Welch.
Hi.
Could you use physics to describe Esalen as a vortex?
Yeah, we could say that. and the other thing I wanted to say was that yesterday morning I was sitting by, there's a new sculpture as of 2003 honoring the Esalen people, the Yenep, that if you walk across the creek and go down towards the big house and towards the ocean, along the fence there's a sculpture and a signage board honoring and blessing their past, present, and future prosperity. And so I encourage you all to spend some time with that. And what I was feeling when I sat there to meditate was, obviously the power in my body of being in this place with this my immediate history, with the history of the people here and the power of the landscape. And what we're talking about here is the dissipation of energy across gradients. And the gradient here between cliff and sea is a very powerful gradient, that we are the vortexes that must dissipate that energy.
Hi, Kerri. Oh,
yeah, great.
hello.
Thanks. Hi.
I have some big questions. You inspired the math kid in me. Just jump in. And so, from your perspective, what is the future of physics? I'm just going to throw that out here. Because I'm thinking there is the Einsteinian, the 4 space-time that physicists like to work with. And now, since you've introduced so much nuances into this one dimensionality of time, can we build a space-time structure with that built-in directionality and all that's unfolding and constellated in that dimension? And how would that be a language to even communicate, and engage as humans? And I guess my second question is this concept of duration, which I read from Henri Bergson and many process thinkers, that attempts to characterize this reality of change. I wonder how that might be able to connect with some of those mathematical unfoldings that you're bringing up.
Yeah, really big questions. And that's going to be our last one because I got to shuffle off and let Drew get set up. But to speak to the future of physics is Gebser's future integral, where we're coming from the archaic and the magical is a synchronistic notion of time, and the mythical is a dualistic notion of time, the once upon a time and the concrete here and now, and the mental is the past, present, and future linear causal time, and the integral is the integration of all of those things. So bringing the gifts of the mental, which is physics, scientific physics, integrating it with the gifts of the mythic and the gifts of the divinatory acausal that lives in the synchronistic. And interweaving all of those and recognizing how they all reflect one another and are talking about the same reality and can each have their own areas of expertise. That's the future of physics.